Bismillahirrahmanirrahim. Today, inshallah, we shall start chapter 5 in Algebra 2. Chapter 5 is about rational functions. And just to give you a preview, rational functions are functions that look like this, or functions that look like this, where the independent variable is frequently in the numerator and denominator, but at least in the denominator here. But we shall talk about these in detail in the coming lessons, inshallah. But today the chapter begins with inverse variation, the concept of inverse variation, which is the heart of these functions. In Algebra 1, we had studied direct variation. Okay. And today we shall elaborate on this and talk about inverse variation. A simple concept of direct variation is when two variables are related, y equals a to the x. For example, if you had a job and then your pay, which is P, was equal to the number of hours of you worked times your the pay that you got, like this. So if this was your pay, let's say you got paid $10 per hour and the number of hours worked. So if you worked for 1 hour, you had $10. If you worked for 2 hours, you had $20. 3 hours, you had $30, etc. So that's an example of a direct variation. So in a direct variation, for example, your pay goes up and to the number of hours that you worked. Okay, so they're both like this. So one is going up, the other one is also going up. If one is going down, the other one also would go down like this. So that's direct variation, and symbolically it's represented by an equation like this, where a here would be a constant, and that's called the constant of variation. Okay. So if two variables are related directly, okay, their relationship is described by this function, y equals a to the x. Okay, and a is the constant of variation between them. Okay, that's a direct variation. We've done that in Algebra 1. On the other hand, if inverse variation is like this, y equals a over x. Okay, in this case, they're inversely related. If one goes up, the other one goes down. If one goes down, the other one goes up. It's like this. So this is the inverse correlation. For example, if somebody puts in their more hours dieting, their weight will go down, right? The more hours they diet, for example, this example, their weight goes down. So that's an example of an inverse variation. The inverse variation relationship is described by this, where a here, in this case, is a constant, and that's, again, is the constant of variation. Okay? So that's inverse variation. So again, this would be direct variation, and this would be inverse variation. Okay. Now, just to elaborate on this example, okay, x and y are inversely related. So this is an example. I'm choosing example number 2 from your textbook in section 5.1. So this is page 303 if you wish to follow. So the variables x and y, we're told, okay, are inversely related. If they're inversely related, then you can write the skeleton equation, so to speak, like this. In other words, that the way they're related is going to be something like this. We don't know what a is, but it's going to look something like that. Okay. And then we're told that when x is 4, then y is 7. We're told this. This is when. right here. We're told that when x is 4, y is 7. Okay. Then we were asked to write an equation or a relation that expresses this relationship between these two variables. Okay. And so this would be like this. So this is the relationship between the two variables, but we don't know what a is, but we're given a set of values that we can use to find the a, the constant of variation. So when x is 4, the value of y is 7. So we can solve this for a, and we get 28 to be a. Okay? So now we know what a is. Now we can write the real equation in this particular scenario. That would be y equals 28 over x. So this is the inverse variation equation for this particular scenario. So as soon as we were told that this was the inverse variation, we can write this presumptive equation, not knowing what a is, and we can find a if we're given two values for x and y, because after this, for any given value of x, we can find the corresponding y, or vice versa. And then we are asked, in fact, told, find the value of y when x is -2. So when x is -2, what's the value of y, we are asked. So that's easy enough. You substitute -2 over here. So y equals 28 over -2. And we realize that y must be -14. Okay. So this is an example of inverse variation. Okay. Again, so this is direct variation, and this is inverse variation. And this is called constant of variation. In other words, that a value does not change once you find out what it is, whereas x, in fact, is the independent variable. In other words, that's the input of this equation. That's the independent variable. Independent variable is another way of saying input, right? Another way of saying input. Now, there's another concept that's related to this, and that's called joint variation. Okay, joint variation. This is a common phenomenon in all aspects of human studies. You know, there are joint variation equations in physics and chemistry, biochemistry, and in economics, in pure physics and mathematics, etc. These are everywhere. But it's important to understand the concept of joint variation, which is basically elaboration on these two concepts. Okay, so because a variable can be related to more than one variable. Okay. So a variable can be related to more than one. For example, a person's health is dependent upon 1, their nutritional status, number 2, whether or not they have chronic illnesses, number 3, their accessibility to routine healthcare, etc. So there are many variables that go into the making of a person's health, for example, right? Okay, how far a person travels in their car depends, for example, how much gas they have, how tired they are, and if their car is properly functioning, or if there are roads there, etc. Right? So there are many variables to a particular given situation. Okay. Similarly, over here, joint variation implies when a variable is linked to other variables. Okay. Okay. For example, when a variable z, okay, is related to more than one variable, such as like this. Okay, in this case, z is related to which two variables? X and y. It could be related to many other variables if you wanted to. Okay, so in this is called jointly related. So z is jointly related to x and y. Okay. And it's jointly directly related, right? It's directly related to x, directly related to y, so to speak, right? So z is jointly related to both of them. So this is called joint relation. Okay. So and also a variable can be related to other variables. For example, I'm just making this up. K is related to some constant of variation a. Okay, to, let's say, x times y, and it could be inversely related to q or something, some other variable, right? So this just describes the relationship of k to all of these variables. But this is very helpful because this tells you this is like a direct variation. When the value of x goes up, the value of k goes up, right? When the value of y goes up, the value of k will go up. When the value of q will go up, the value of k will go down because they're inversely related. They are inversely related, okay? So this is a very important concept to appreciate in that manner. Okay, so allow me to share with you this example. Example number 5 from your textbook from the same section. The example says the variable z, okay, varies jointly, means more than one, with x and y. So you can, just with that statement, you can write the presumptive equation. Z is going to equal to, I should use the same z. Z is going to equal to sum A, which is the constant of variation, times is jointly related to x and y. Okay, that's what we're told. So this is the presumptive relationship between these three variables. And then we are told, we don't know what A is, see? We don't know what A is, but it's some constant, it's a number, okay? We won't be able to find out unless we know one set of data, okay? And then we are told, so when z is negative 75, okay, this occurs when x is 3 and y is negative 5, okay? So these are the circumstances. In other words, when x is 3 and y is negative 5, z is negative 75. So we can substitute those values into the equation like this, and then we can solve for A. Okay, x is 3 and y is negative 5. Okay, so that is negative 15a divided by equals negative 75. A then is going to equal to negative 75 divided by negative 15, which is 5. Okay, so now we know the constant of variation. Has constant of variation. Okay, now we know the real equation for this, so to speak. Z is going to equal to 5 times x times y, right? So this is the equation that represents the relationship between these three jointly related variables. Okay, so today we learned about one concept, we reviewed one concept, which was direct variation, V-A-R-I-A-T-I, variation, which was y equals a times x, and then we learned about inverse variation, and this was y equals a over x, and we also learned about joint variation, and it was like this. So this is the beginning of this chapter, and these are very important concepts, in fact, and very useful in daily mathematical endeavors. So I hope you appreciate that and know this very well, inshallah. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.